Hey guys, in this video I'm going to show you how to diagnose a P0017 cam crank misalignment code. Now the computer is taking the assumption that you're full of oil and your oil is clean and the right viscosity. Now first I'm going to take a look at the live data. I have a MaxiSys scanner, but you do not need a full high-price scanner to do this. You could just adjust anything that'll read live data, and you can see where your target cam and where it actually is to see what kind of situation you're in. If any of these are not met, or you have dirty oil, wrong viscosity, low oil pressure, it'll also set a cam crank correlation code. Now VVT is a variable valve timing. On the later engines you can actually adjust how much advance and retard the cams are. In this video I have a 2007 JEEP COMPASS 2.4 dual overhead cam, which has dual VVTs. That the VVT is not able to meet the target of 120. Now this code is set on account of the cam is not in the position that the crank has asked it to be in. For instance, if it's looking for a target of 120 and the target is 80, then it knows that it cannot achieve that target, so it sets a code. In this video I'm going to show you the easiest steps that I take in the quick steps to actually determine where the problem exists, because what it's looking for is, the logic is looking for a cam crank misalignment. So it's asking for the cam to be in a position of 120 and the cam is actually in position of, say, 68, for example. When it goes and when it sees that it cannot achieve this point of 120, then it'll set a code. And I'm going to show you the steps I go through to diagnose and repair this P0017 on this 2007 JEEP COMPASS 2.4 double overhead cam. And if you look in this video, it shows the target and what actual is. So that right there will give us the first clue of what's going on with it. I will also look at the both cam sensors and see if it's holding pretty steady. If it's real erratic, I might think it's the cam sensor, but in this case it's not the cam sensor. So I'm going to show you how to check your VVT solenoid. Now VVT solenoid, it takes the oil pressure from the engine and on a dwell factor applies oil to the VVT, and the internal logic of the computer will look and see if it's actually changing, and it'll adjust the dwell in order to get it to its target. And once it achieves its target, it'll hold the dwell there. Now because this engine has an intake and an exhaust cam sensor, and the intake does not show any problems with it, you can pretty much eliminate your crank sensor and your oil and your oil pressure. And when the computer asks for a certain target and it doesn't see it, then it's going to set a correlation code. Now because it's just on one bank, we can pretty much assume our oil and our viscosity is in good shape. So I have checked the basics and checked it's full of oil. The oil is a little dirty, so it tells me it's been in there a while, so the viscosity should not have changed. Now because it doesn't have a circuit code, that pretty much tells you that your electrical circuit is good. For example, in this video it shows that the exhaust cam is targeted at 120 and actually is 68. So that tells us that the VVT is not changing enough to make the difference. Also in this video, if you'll notice, I have an engine oil pressure low circuit. That is due to the engine previously, just before stalling, the oil pressure had dropped too low. So that is a effect from the cam crank correlation and the engine starting to die. Now like I said, since how it's not got a circuit code, it's showing a performance code, so we don't worry too much about the electrical part of it. We are going to check the VVT solenoid to see if it's doing what it's supposed to do. Now in most cases it is the VVT solenoid, So we'll check it first and show you what to do and what it's supposed to get. Now cam solenoid activates the cam actuator. It turns on and off in a dwell cycle to change the oil pressure in the VVT cam actuator, which changes the cam position, which the cam sensor picks up. And if it doesn't see a correlation between it and the crank, it may set a crank correlation code, but it's got two sensors, and if only one of them's setting it, then it's only going to be on one bank, and this one's on the exhaust bank. All right, this is our exhaust cam. It's actually at 87. It's looking for minus 120. And if you look, our intake is at 120. It's looking for 120, and it's actually at 120. All right, so this is your front solenoid intake. That's the sensor for the cam to say what positions it's in, correlating with the crank. This is bank 1 sensor 2 exhaust. There is your cam sensor, and this is your solenoid. And what it does is it applies oil to the VVT, and it adjusts the cam back and forth, and it's probably stuck. Once it gets hot, it sticks, and it's not closing back up to adjust the valve. The cam timing according to the crank, and this picks up on it. The sensor back here picks up on it, so it's bad. Okay, now then, I want to go to active test, and I'm going to go exhaust VVT state control. Now then, I want to go to the ground side of the battery, because we're going to induce power to it. Well, if the switch is on, it's going to have power to it. So while the ignition switch is on, it'll always have power. Now we'll check our test light. Now then, we're going to set this to the side, and we're going to disconnect the solenoid. That'll be the hot side when I turn the switch on. Alright, let's turn the switch on. Test light's normal. Now then, we're going to switch under active test, VVT control. Alright, now then, we're going to make sure you don't get this near any metal. Now I'm going to take this, take it to the hot side. I can get it disconnected. Now we want to check and make sure that everything's working on it. Alright, we got a good hot connection. Now I should be able to toggle that to on. Notice I got a test. My light is lighting up. Now I'm gonna go over here, toggle it to off, which is 2. Test that one off. On. It's on. Off. On. So that part's working. The solenoid is not clicking. Now let's escape that. Which is on. VVT exhaust. I should be able to hear it and feel it click. Which which I do not feel. Now that we're there, let's see if we can get this one over here to click. Should be able to do the same thing with it. So let's escape that. VVT intake control state. Hear it clicking? All right. Now we have proven that's bad, and what we can do is when we remove it, we can add a 12 volts, because it's just straight 12 volts. We can add 12 volts to it, and it should click. Now here's what we're looking at after replacing the exhaust VVT solenoid. Looks a whole lot better. I want to thank you for watching, and if you like this video and want to see some more videos, I'd appreciate it if you hit like, subscribe. My name's James Noble. Have a good day.